Hello, Algebra 2 students. This is a video for example 3 of section 1.6. We're going to solve a system of equations with three variables. So there's an x, a y, and a z. And this video that they have shows their way of doing it. In my years of algebra, their way of doing it just seems to confuse students all the time. I'm going to try to show you my own way. Hope you don't mind. This is how I would tackle this problem. I need to combine either equation A and B, or B and C, or A and C. So I need to combine two of them to eliminate either X, Y, or Z. And looks like if I combine these two, I can get rid of Z. If I combine these two, I'll get rid of X. Now you have to pick, you can only pick one, and once you pick it, that's what you have to get rid of in the other equation. I'm going to get rid of Z because you're probably used to solving equations that are working with equations that have X and Y in it. So looking at these two equations, I'm going to add them together because it's already set up with a positive at Z and a negative Z. So when I add them together, the Z's will cancel out. 2x minus x equals x. Y plus 2y equals 3y. Negative z plus z comes out to 0. That was my goal, to get rid of z. And negative 10 plus 3 equals negative 7. Negative 7. Now I need to get rid of z. Let me change colors for effect. I need to get rid of z by combining these two or by combining A and C. And I have a 3z and a z, and I have a 3z and a negative. So it doesn't really matter. It's not really set up that easily. So I'm going to have to do a little work. I'm going to multiply the A by 3 over here. 3 times 2x is 6x. 3 times y is 3y. 3 times negative z is a minus 3z. That's why I chose 3. I chose 3 up. Whoops, that's a pretty big z. Let me try that again. I chose 3 on purpose. I chose to multiply by 3 on purpose because I needed to get the opposite of plus 3z. So that's why I multiplied this by 3 to get negative 3z. And negative 10 times 3 is negative 30. Now I'm going to combine that one with equation C. That's what I was setting up to try to do that. This has x and 2y and positive 3z. Okay, so reviewing again, the first step I needed to do was identify, do I want to get rid of x, y, or z? I chose to get rid of z. The first thing was pretty simple, to add in red those two equations to get rid of z. But in order to get rid of z out of by combining another two, I had to multiply a by 3. You might think this is confusing, but believe it, it's not as confusing as what they have on that video. Now it's set up nicely for me to add the two equations, and z will cancel out. I need z to cancel out because z canceled out on this one. 6x plus x is 7x. 3y plus 2y is 5y. And negative 30 plus 13 is negative 17. No, it's not. Yes, it is. Negative 17. All right. Now I have two equations and only two unknowns. Right. These are the two equations I have left because I got rid of the z's from combining two and then another two. So now I want to look at these two and see what I need to do. That's a 7x. That's a positive x. That's a 5y. That's a 3y. It's probably easier to get rid of the x. In fact, if I multiply this top equation by negative 7, if I multiply all of these by negative 7, I'll have negative 7x, and I can combine it with this one. So I'm going to multiply by negative 7 and plug it right down here. Negative 7 times x is negative 7x. Negative 7 times 3 is negative 21. Negative 7 times 3y is negative 21y. And the constant, negative 7 times negative 7 is positive 49. I did that on purpose, so now I can combine these two equations. When I add these two, I get 0x. That was my goal. 5y plus negative 21y is negative 16y. Negative 17 plus 49 is 32. Oh, this is going to come out nice. Now I just solved this for y. After all that, it took all of that just to figure out what one of the letters was, one of the variables. When I divide by negative 16, I get that y is negative 2. Now I need to figure out what x and z are. So I take this y equals negative 2, and I'll plug it in to one of these two equations. Which one looks... I'll do the top one. 7x plus 5 times, to save some time, negative 2 times 5 times negative 2 is negative 10, so I'm going to change it right now to negative 10, or minus 10, equals negative 17. I'm trying to solve this for x. I'm going to add 10 to both sides, and I'm going to get 7x. When I add 10, I get negative 7. Divide both sides by 7, and I'm going to get x equals 1. Now that I know x is 1, and I know y is negative 2, I'm going to take both of these, and I'm going to plug it into one of these original ones. 2 times x, what was x? Positive 1, or is it negative 1? I solved it and then I forgot. Add 10, I get negative 7, divide by 7, and I get negative 1. Oh, that was close, I almost wrote 1. Negative 1 plus y minus z, plus y minus z, plus y, so plus the negative 2 minus z equals negative 10. Now you probably got confused with me going back and forth. All I did was plug in negative 1 in for x in this top equation. You can pick any of the three, but I just picked the top one. I plugged negative 1 into there. I plugged negative 2 into there. And the negative z, I don't know z yet, that's what I'm trying to figure out. And the negative 10 there. So now I can solve for z. This is negative 2. Negative 2 plus another negative 2 minus z equals negative 10. Negative 2 plus negative 2 is negative 4. Negative 4 minus z is negative 10. Getting close to the end. Bear with me. Add 4 to both sides. Negative z, when I add 4 to this, I get negative 6. So negative z equals negative 6. If negative z equals negative 6, that means z must equal positive 6. So my answer for x, y, and z is 6. Z is 6. X is negative 1, and y is negative 2. That's my answer, those three things combined. Let's see how I did. Negative 1, negative 2, and 6. And we'll go to the end of their video. Negative, oh, did you see it? It was right there.
Equals negative
1, negative 2,
y equals
and
negative
6.
2,
Nailed
and
it.
z equals
Let's
6.
see what else we have. Or how long has this video been? Maybe it's been too long. I might need to do a part B. What is the solution of this system of equations? Okay, so again, you want to pick an x, y, or z and get rid of it from two equations. And then it will be down to what I wrote over here in blue and green. You'll have two variables. Then you need to combine the two equations into one, and then you'll have one variable. Then you plug it back in to get the other variable, and then you're going to plug them both into the original, one of the original ones, to get the final equation. Okay? Since this video is going quite a while, I'm going to ask you to click pause, give it a shot, and then when you come back, I'm just going to click the answer. Okay? All right, you're back. Let's go through their solution to get their answer. oh, maybe I should have done this out. Turns out at some point you get 0 equals 6, which is not true. So there's no solution. Do you remember that from algebra? If you ever get the variables cancel each other out? So that's what happened in this one. The variables canceled each other out somewhere, and it ended up being an inconsistent system. All right? How about this one? These two should work out. So if you click pause, try both of those, and come back when you're ready. All right? And your teacher may want to go over these in a little more detail, but there's the answer to the first one. X was 1.5, B was 1, and I'm sorry, X was 1.5, Y was 1, and Z was 0.5. If you haven't already done so, click pause, try this one, then come back when you're ready. And we had, this one had no solution. It ended up with an inconsistent situation, just like the previous example. All right. I know that probably didn't explain it that well for you, but this has been a long video, and let's see what problems you should be able to do from the book. Check with your teacher to see what they want to assign. 22, 23, and 13. That's it for this video. Have a great day.